Okay, since it's 11, I'm going to go ahead and get started. Today we're going to do two sections, 7.1 and 7.2. 7.1 is on different kinds of symmetry. Okay, and symmetry just means that you're the same on one side of something as you are on the other. So what we're going to look at is being symmetrical with the x-axis, symmetrical with the y-axis, and symmetrical with the origin. If you're symmetrical with the x-axis, that means either side of the x-axis mirror each other. If you're symmetrical with the y-axis, that means either side of the y-axis mirror each other. Okay, so we're actually going to do number 2 and number 3 first, if you have your handouts that I sent. Okay, so we're doing these two first, number 2 and number 3. And then we'll come back to this one because it's a little harder to see that kind of symmetry. Okay, so on number 2, you'll notice here's my x-axis, here's my y-axis, and it's asking you where is it symmetrical to? So if you're looking, here's my y-axis. And if I could actually fold this board like a sheet of paper on the y-axis, this side would come over and lay on that side. They are symmetrical to each other. The same thing is on the left side is on the right side. So this one would be symmetrical with the y-axis. Okay, on number 3, if you'll notice, here's my x-axis. And again, this side of the x-axis mirrors the bottom side. The top and the bottom mirror each other. Or in other words, if you could fold this like a sheet of paper, this part of the graph would come and lie on this part of the graph. So this is what it looks like if you are symmetrical with the x-axis. So those are those two, number 2 and number 3, symmetrical with the y-axis, same thing on both sides of the y-axis, and symmetrical with the x-axis, which means the same thing is happening on both sides of the x-axis. Now, something that's a little different, like you'll see on number 1. Okay, so here's what number 1 looks like for the most part. Okay, so it's not symmetrical with the x or the y, because if I folded this side over to this side, this part, this hump, if I folded it over here, would actually be down here, right? If I folded it on the y-axis. And same thing, if you folded it on the x-axis, this would come down here and the hump would be down here, not lying on this. This is what's called symmetrical with the origin, and here's why. If you rotated this half of the graph 180 degrees, so again, just taking this part and rotating it 180 degrees, then it would lie on this part of the graph. So again, what I'm trying to say, this is harder to see than just being symmetrical with the x or the y. Okay, you'd have to actually fold it both ways or rotate it 180 degrees, and then this part of the red graph would rotate and come and lie on the other part of the red graph. So this is what it looks like if you are symmetrical with the origin. And the origin is just this middle spot right here. So again, rotating it 180 degrees would make one part of the red graph come and lie on the other part of the red graph. So that's what it looks like if you're symmetrical with the origin instead of the X or Y. Oh, there you go. Yeah, thanks, Paula. So okay, it's kind of like the Z-axis, which would be coming out this way. Like three-dimensional. Yeah. Okay, the last two problems in this section, there's only 5, are talking about even and odd functions. So let's look at what that means. If you are, let me write it up here first. And I'll give you some examples of these. Okay, even functions are functions that are symmetrical with the y-axis. For instance, x squared. Okay, an x squared graph like x squared is even, right? Because the 2 is even. What do x squared graphs look like? They are parabolas or that U shape. So if you'll notice, here's my y-axis. If I folded it on the y-axis, part of the x squared graph would lie on the other part of the x squared graph. So if you're an even function, you are symmetrical with the y-axis. Odd functions like x cubed that's what the graph of x cubed looks like. You are symmetrical with the origin. So just like that last problem, if I rotated this 180 degrees, it would end up, if I rotated this part of the red graph 180 degrees, it would end up lying on this part of the red graph. Or in other words, if I flipped it across the X and then across the Y on both of them, then that would be symmetrical with the origin, or we can call that an odd function. Okay, so let's use this information to look at the graphs on number 4 and number 5 from this assignment. Okay, here's what the graph of number 4 looks like. And it wants to know if it's an even, odd, or neither, which means if it's even, that means it'll be symmetrical with the y. So if are both sides of the y-axis doing the same thing here? They are. They mirror each other. It's like they're looking at each other in a mirror. So that's why this one is an even function, because it's symmetrical with the y-axis. And the last one Okay, actually, that's not good at all. Okay, so if you're looking at your sheet of paper, this is what it looks like, and it wants to know if it's even or odd. Okay, so it's not symmetrical with the y-axis, right? They're not mirroring each other. Here's my y-axis, and if I folded it over here, this hump right here from this graph would just end up right here and not lie on this part. But if I rotated this 180 degrees or flipped it across the x and then across the y, then it would lie on the other part of the graph. Okay, so you can think of it as two different ways, either rotating it 180 degrees or flip it across the x, then across the y. And if in that case, like if I flip this hump here and then over here, it would lie on this part. Okay, so that's why this one would be an odd function. Okay, so that's all that is in 7.1. And the other section that we're going to cover is the 7.2 section. So I'm going to write some things up here for 7.2 before we get into the actual work. Okay, and this is actually how my college algebra instructor 25 years ago explained it to us, and it's stuck. So I think it's a good way to explain it by calling these inside and outside numbers. And I'll talk about what that means here in just a second. Okay, so inside numbers, and we'll talk about what that means here in just a second. They're going to shift the graph horizontally, left and right, okay? But you're going to go opposite of what the sign is. So if you're an inside number, like a +5, you're actually going to shift it backwards or to the left 5. And I'll show you what that means here in a second. The outside numbers, which are numbers that are not in the parenthesis or not in the square root symbol, they're outside of it, are going to vertically shift the graph or move it up and down. But you're going to go with the sign on those. Okay? So let's talk about what inside and outside numbers are. Okay, when I'm talking about an inside number, I'm talking about the numbers that are inside the parentheses or inside of a square root symbol. These are the numbers that shift the graph horizontally, left and right. You go opposite the sign. So this one would actually shift this graph, since it's a +2, it would shift it to the left 2. This is an outside number, one that's not inside the parentheses, but outside of it. This vertically shifts your graph up and down, and you go with the sign. So a -5 would actually shift this graph down 5. Now, what is the graph that it is shifting? Well, whatever is being done to the x, which in this case, it's being squared, which means it is a parabola or a U-shaped graph. So an original parabola that hasn't been shifted anywhere at all would be right there at the origin. This graph, however, it's going to have the same shape. It's going to be an x² graph still. It's just that the middle of it, this point right here, is going to be shifted to the left 2 and down 5, which means it's going to look the same. It's just that this point right here is going to be shifted to the left 2 and then down 5, which will put the middle of it here and still be the same shape. So that's what these numbers do. They shift it left and right and up and down. Okay, so let's look at some of these for 7.2, like number 1. And then after I do number 1, I'm going to actually show you how you would do that, because these are different when we're doing them in Math Lab than what we're used to. Okay, y equals x minus 8 squared. So what it's going to do is it's going to give you these choices. The thing that's different between these choices are where it's being shifted. Where is it moving? Where is it? 8 spots. Okay, so since that's an inside number, remember, inside numbers shift you horizontally, left and right, but you go opposite of the sign, which means since this is a -8, it's actually going to shift this graph to the right 8. So you would go and find the one that says right 8. Which will be that A, right? Shifts it 8 units to the right. Now, here's what you put in here. What is the shape of the graph? What's giving it its shape? What is the original shape that you are starting with, which would be an x² graph. So an x² graph that is shifted to the right 8. Now, let's see what this looks like in MATLAB. Okay, do y'all see the problem? Y'all see the problem right now, don't you? The y equals x plus 4 squared. All right, I'm gonna assume that y'all see that. So what is happening is that x plus 4, since it's plus 4 on the inside numbers shift you left and right, but you go opposite the sign, which means it's going to be an x squared graph shifted 4 units to the left, which would be this D answer. So you would just click the D and type in x squared and hit enter. Now, when I graph this, click to enlarge. What you're going to do is come over here to the palette and choose your shape. Since it's an x squared, you're going to use, it's called the x squared tool. It's that U shape. Now, instead of plotting points like we've done before, because this section is focusing on the shifting of the graph, you actually just come over anywhere. Like you can be up here even in this top corner and just hit enter. So it puts the original x squared graph right there at the origin for you, and then wants you to do the shifting after that, okay? So we need to tell it to shift 4 units to the left. So you'll see this box down here that's got all these different shifting and all that. We don't do any shrinking. It's all shifting in this section. So these bottom 2. And it's a horizontal shift to the left 4. So watch what happens when I move this box. You'll see that yellow parabola moving. So I'm moving it to the left 4, to -4. And hit enter or save. So that's what you're going to do on these in MATLAB. You figure out where you're going to shift it, and then you're going to tell that shape to do that shifting instead of actually plotting points. Okay? All on except number 2. Okay? Number 2, which is what we'll do now. Okay, so it says describe how the graph of g of x equals x minus 9 can be obtained from one of the basic graphs. So it wants to know, first of all, what is the basic graph? So this x is not being squared or cubed or square root or absolute value or anything. So you're actually just starting off with the graph of x, which is just going to be a line or linear. This minus 9, it's not inside anything, right? If it was inside, you would see it inside some parentheses or something like that. It's not inside anything. So that's an outside number, which means the graph of x is going to be shifted down 9 because outside numbers shift you up and down, and you go with the sign. So since that's minus 9, I'm going down 9. Now, when you do this one in MATLAB, this is the only one that doesn't give you that whole shifting up and down part because it's a line. What you're doing is you're just going to plot 2 points like you always do, which means if to find 2 points, you would just go to your y equals, type in the x minus 9 if you wanted to see it. So there it is. It's a line that has just been shifted down 9. And you're going to plot 2 points on that line, which just means hit second table and choose any of those 2 points that you want to plot. All right, number 3. Says, describe how the graph of h of x equals 1 over x plus 5 can be obtained from the graph of 1 over x. So again, it's just talking about this shift right here. Since that's a plus 5, it's outside, right? It's not inside anything, it's outside. That means it shifts it up or down, and you go with the sign. So that plus 5 tells me I'm going to shift this graph up 5. And this one's actually a multiple choice. So here's your 3 options. The original, just 1 over x, would look like this, right? Right centered right there at the origin. This one is actually this graph shifted up 5. And that one's that graph shifted down 5. So you would choose this one because that's the one that has been shifted up. Okay, before we do number 4, so we've talked about horizontal shifting left and right. We've talked about vertical shifting up and down. Sometimes graphs are flipped upside down. And we've seen this before, right? We've seen it with an x squared graph. Right? A regular x squared graph is just that U-shaped parabola. And we've seen this before. What this negative does to it is it flips it upside down. That's what makes the parabola go upside down, is that negative in front of the x. Okay? That's not really a mathematical term, flipping upside down. The way that they say this, the way that you mathematically say that is this negative will reflect the graph across the x-axis. Okay, it turns this graph and it reflects it and flips it upside down. It reflects it across the x-axis. Okay, so now we know the shifting, and now we know reflecting across the x-axis. So let's look at number 4. And then I'll just show you this one into MathLab also. So let's see, what 2 things are happening? First of all, you're starting off with an x cubed graph this time. So that's what you're starting with. That's the tool that you're going to choose over in the palette. You're going to use your cubing tool, which has, it's this shape right here. Then 2 things are happening to the shape of this graph. It's going to, since this is an inside number, that's a horizontal shift. But you go opposite the sign. So I'm actually going to go to the right 7. This negative is going to flip this shape upside down, or in other words, reflect it across the x-axis. So let's see how that looks in MathLab. So we have negative, and then in parentheses, x minus 5 to the 3rd power. Okay, so we're going to start off with an x cubed graph. So the -5 is in parentheses, which means it's actually going to shift it to the right 5 units and then reflect it across the x-axis because of the negative in front of the parentheses. So right 5, then reflect across x would be this C wording. So that's where we'll type in the x to the 3rd power. Oops. So now let's see how we would graph that. So since it's an x cubed graph, you're going to choose that x cubed tool. And again, you can click anywhere you want in the whole graph. So we're going to do 2 things. We're going to shift it horizontally to the right 5. So come down to your horizontal shift and move it over to the right 5. Now, below that, you'll see these reflecting tools. So I want to reflect it over the x-axis. So you're going to do a vertical flip. So watch what the yellow shape does once I click this. It'll flip it upside down to that. And then save it. Okay? All right, number 5. Okay, so it's going to give me 3 blanks on this. So start with the graph of f of x equals. So what's going to be my shape? It's going to start off with the x squared graph. And then it has 2 blanks. It has blank 2 units and blank 3 units. So let's see. The 2 units is coming from this shift right here. Again, inside numbers shift you left and right, but you go opposite the sign. So since that's a +2, I'm actually going to shift to the left 2 units. And the 3 units blank. So that's going to come from this number. It's an outside number. My outside numbers shift you up and down. And you go with the sign. So since that's -3, I'm going to shift that shape down 3 units. Okay? All right, number 6. You have f of x equals the square root of x plus 9. Okay, so this one's another multiple choice one. This x plus 9, so this plus 9 is inside of that square root. So it's an inside number. Inside numbers shift you horizontally, but you go opposite the sign. So it's going to be the shape of a square root graph. A square root graph looks like this. And it's going to shift it, since it's plus 9 on the inside, it's going to shift it to the left 9. All right, number 7. So this one's different, right? Because this -3 is not inside the cube root. It's outside. It's not underneath. It's not inside. So this one is a vertical shift, up and down shift. Then I'm going to go with the sign, right? So with that sign means I'm going to shift. The cube root graph looks like this. That -3 is going to shift this shape down 3. All right, last one. This one has a little bit of everything. Okay, so we have negative, and then in parentheses, x -5 squared, and then +3. So you always do your horizontal shift first, then your reflection, and then your vertical shift. Okay, you don't want to do your reflection before you do your vertical shift, because then you'll do, or you don't want to do your vertical shift before you do your reflection, because then you'd be reflecting the wrong thing. Okay. So my horizontal shift, which is what would come first. Now this is going to give you a drop down, and it kind of gives you a little hint, because it's going to just say a bunch of right and left options. Okay, so what is this telling me to do? It's an inside number. Since it's -5, I go opposite of that. So I'm actually going to go to the right 5 units. Then it says reflects it across what axis? So this negative right here is what turns that parabola upside down. So again, that's going to reflect it across the x-axis. And then after the reflection, where is your vertical shift? Your outside number tells you that. So the vertical shift tells you +3, which would tell you to move it up 3 units. Okay? All right, so that's all.